In this example, I'm going to teach you how to factor a high-degree polynomial using the factor theorem and the factor property. So let's define the factor property first. It states that if x minus a, where a is the member of the integers, is a factor of a polynomial, then a is a factor of the constant term in the polynomial. So right now, yes, it's a lot of words. So let's actually go right into it and apply it. So here's my first example here. It says, fully factor the polynomial p of x is equal to x cubed plus 3x squared minus x minus 6. Now, as you can see, they don't give you any factors. So we're going to use the factor property to find one. So this theorem states that we want to take a look at the constant of our polynomial. Now, let's look at the polynomial. The constant is the last number, -6. So that is the constant. And we want to find the factors of this number, -6, and not only the positive factors, but all the negative factors as well. So all the factors are 1, 2, 3, and 6. So these are all the numbers that divide evenly into 6. But we want to find the integer factors, so we have to consider the plus and minus case for each potential 0. So there we go. We have what we call our potential zeros, and they're called potential because we don't know if they are zeros. So we have to actually use the factor theorem to find which one is the 0. So you pretty much have to start anywhere between 1 and 6. So let's start with p of 1. So let's check if p of 1 is equal to 0. And if it is, that means we have a factor of x minus 1. So we want to check this. We want to check p of 1 first. So p of 1 is equal to, go back to your polynomial, wherever you see an x, you're going to plug in a 1. So 1 cubed plus 3 times 1 squared minus 1 minus 6. So if I simplify further, I get a 1 plus a 3 minus a 1 minus a 6. So if I add all these numbers together, I get a value of -3. So that is not a 0. That means, therefore, x minus 1 is not a factor. So this one didn't work out, but there's plenty more to choose from and to check. I'm going to choose, let's try x is equal to -2 to see if this one works. So wherever you see an x, you're going to plug in a -2. So -2 is equal to, p of -2 is -2 cubed plus 3 times -2 squared minus a -2, so be really careful with the signs, minus 6. So let's evaluate even further here. P of -2 is, -2 cubed gives me a -8. 3 times a -2 squared gives me a +12. And a minus -2 gives me a +2, and finally a -6. Now, if I add all these numbers together, I get, extend the page, P of -2 is equal to 0. So we have found a factor. Therefore, x plus 2, be careful with the signs, right? So we proved that p of -2 is equal to 0. Therefore, x plus 2 is a factor. So we have found a factor. To find the other ones, we want to divide our polynomial, p of x, by our binomial, which is x plus 2. So I'm going to go back up here, and I'm going to pretty much erase what I did here. And here we go. So we're going to divide using synthetic division. You don't need to use synthetic division. You could use long division, whatever you're most comfortable with. So we know that x plus 2 is a factor. So we want to divide p of x by this binomial, and I'm going to use synthetic division. So the number that goes in front is a -2. My coefficients are 1, 3, -1, and -6. So we didn't have any placeholders. Everything was in descending order already by degree. So bring down the 1. We have a -2 times a 1, which is a -2. 3 minus 2 gives me 1. 1 times a -2 is a -2. Add those two numbers together, we get a -3. And -2 times -3 gives me a +6. Now, if I add these two together, we do get a remainder of 0, which makes sense because we know that this is a factor, so there should be no remainders. So the the factorization that I have so far is x plus 2. And the next factor comes from the bottom numbers of my synthetic division, and that is x to the power of 2 plus x minus 3. So far, that's what I have. So keep checking. We want to completely factor this polynomial. X plus 2, we can't do much with that. But look at this. We have a quadratic, so try to PSA it. So PSA, my product is -3. My sum is +1. So take a look at this, and I don't think there are any numbers with a product of -3 and a sum of 1. So we have no numbers. So what does that mean? Well, that's all you could do with it. That is already in factored form. You can't go any further. So therefore, my factored form is this. And that's how you use the factor theorem along with the factor property to factor polynomials.